Hello everyone, this is Himanshu and today we'll be solving one of the NEET code problems. So screen now. So this is one of the question from the NEET code that I will be solving. So it says that we have a array nums where nums I represents the amount of money the ith house has and the houses are arranged in a straight line. Sure, that is the ith house in the neighbor of I minus 1 and the I plus 1th house. So you are planned to rob money from the houses, but you cannot rob two adjacent houses because the security system will automatically alert the police if two adjacent houses were broken into. So the only consent is we cannot rob the two adjacent houses. So what we have to return is the maximum amount of money you can rob, and that too without alerting the police. Sure. So like let's say this is an example. So the maximum that I can rob is 4. That means that if let's say I am at any index, let's say this I cannot rob I minus 1. So let's say with this amount of money, either the max that I can rob is till here, or I can rob till here plus this one. Sure. So I understand this. So I think this can be solved using the DP problem because at each point it depends on the prior one. So let's think this way. So let's say n to be the size of nums. So what we will be doing is at each index uh, what we will find is like dp of I, the maximum that we can rob, will be equivalent to max of uh, nums I plus dpi minus 2, like how much we can rob till that point plus if we are robbing that point, or uh, DPI minus 1, meaning that if we are not robbing that house, how much we can, what's the maximum that you can rob till I minus 1. So this DP is just dependent on the index. So I think when we like if we have, we can just maintain one DP array, and then from there we can find out what is the maximum uh, amount that we can rob at in index I. So let's say n is length of nums. So here we go, and then for let's say I in range n for each one, we have to iterate. So let's create a DP first. So it's a DP was uh let's say it is filled with 0. So since we are taking maximum of it, and the size will be n, all right. So this is our DP, and what we can do is initially we can just point it to uh, the initial value will be nums of 0, the first index that we have, and the first index can be uh, let's say max of, right, nums of 0, whether we'll take that one or nums of 1. So yeah, this will be DP of 1. So here we go. This is what things would look like, right? Okay, let's do it. So we can, if n is greater than 1, right? If n is, this will only happen when n is greater than 1, right? That is the size. So it's 1, yeah, it should be 2, right? Only then it can have. Yeah, I see. So this is what it is. And here we can range I from 2 because we have already filled 1 and 0. And then we can say that dpi is the max of dp, uh yeah, I minus 1, or nums of I uh, plus dp I minus 2. So since 2 I minus 2 will be 0. And then we have to just return dp minus 1. So this is what I'm thinking. Let's just run it. Just submit. Wow, yeah, it got submitted. So now let's see what improvement can we make. So some of the improvement that can be done here is, think of, instead of using this big line, we can just range till else n, so it will just start from 0, or uh, sure, we'll be having a db for sure. Let's put, okay, num 0 will be 0 as the base condition, and let's move I from here. So this will be the case, right? Okay. And here one problem is, what if dp I minus 2 does not exist? So if I is less than 2, uh, okay. So what we can do is, here we can say plus, uh, is there some operator like if dp I minus 2 plus dp this one, if dp I minus 2 uh, else 0. Not sure if this implementation works or not, but just run it. Wait, do? No, right? Is uh, this will be if uh, I minus 2 uh, is, let's say, greater than or equal to 0, right? So only if this condition is satisfied, we will be using dp. Okay, so it should go like plus dp I minus 2 if I is greater than or equal to 2, otherwise 0. Correct? So yeah, I think this runs. I'm not sure about the other part. So they are failing. The output is 1, expected is 2. So here it is max of dp. Okay, max of 1 comma num psi is not going till 2, right? We are just changing 1. I is 1, dp 0 comma num of I, that is 2 plus this one. What if I just put it in bracket? Does it help? Is greater than 0, right? Oops. Just run it. Wow. So this is the bracket is the case, right? Can also change 0, and we can say it to be uh yeah, we have to use the same notation, but I think that's fine. Yeah. So that's all. This is what my solution will be. So let's look at the solution ones, how these guys are solving it. So yeah, the time complexity is O(n), the space complexity is 1. Oh wow. This is something that is amazing. They're just using O(n) space complexity. I think I should have thought of this before that, because we are just needing the 2 more indexes. So let's re-implement their part. So what should I do? I should first clear it out, reset it, and let's just implement that way. So let's say n is length of nums, right? We can have a temp which will be equal to 0, or let's say A, right? A which will be equal to 0. Just have a B should be equal to nums of 0 for I in range, for I in range 1 to n. Uh, yeah. So here temp equal to, let's say temp is equal to B, B equal to max of B equal to max of temp, comma, psi plus E, right? Yeah. It will be is equal to max of psi and A is equal to temp. B is this guy. We are looking for this guy. Guy will be equal to the max of this guy, and that is, yeah. And then we are just assigned A equal to temp. Sorry. You- so let's say when we are looking for 1, so this is just the storing what is the previous one, and in the 1 this will be the max of uh in that index plus the 2 before that, and versus the one that we have already computed, right? And then we just have to return. It will go to n. So yeah, we just have written B. Let's check, right? Wow. So let's check with the solution. So they are assigned both to be 0. They are okay. They are also going through both of the indexes, and then at each point, the temper is the max of both 2 and row 1 equal to, yeah, it also works. Makes sense. So let's move to the next question. Yeah, here you go. That is the robber's house too. I think this is what we solved, right? Yeah, let's move forward. Okay. So any difference? This one, I think, yeah, okay, this is the difference. Different. So you are given an integer array that is nums, where nums I. So let's first see what are the things that we have. So here we have given an integer array that is nums, where nums I represent the amount of money the ith house have. The houses are arranged in circle, and the first house and the last house are neighbors. Okay. So the one changes is here. Nums where nums I represent the amount of money the ith house have, and the houses are arranged in circle. That is the first house and the last house are neighbor. Okay, so this is in the form of the circle. So you are planning to rob money from the houses, but you cannot rob two adjacent houses because the system will again alert. So we have to return the maximum amount of money that can be robbed. Okay. So now here the problem is, uh, so Scarlet Draw, Scarlet Draw. So here what is the thing is, so there is a circle. Houses are arranged here, and the houses lie, let's say, on the circle. So there are multiple houses. So in this case, since the problem here is the people cannot rob adjacent houses, the person cannot rob adjacent houses because the system will flag, or the sign will. So now I think the problem starts from two way. The first is we can start from here. And then when we are starting from here, we cannot drop this one. This is the implicit, right? So we can have the vector stop here and then we can just consider this part, right? And then once we have done in this way, we can, when we want to include this, we can start from here as our first value and then we can like explore all this part. So this can take two separate runs and then we can output, okay, which one uh, will be our better approach, right? And yeah, that part should work. So yeah, I think this, so we can have the two part. One way we'll include this and then we'll go forward, and the other way that does not include this and then we will go forward, right? So let's try to implement that way. Well, this is not the optimal. Let's think whether we would be able to go side by side, if that is possible. By side meaning that uh, so let's start with here. We'll be having some value. This is the value. Then when we reach here, we'll be having some value again. And when we reach here, we'll be having the value again. But I have one question, like this all the value is positive, right? The person, is it possible to take a leap of two house like this? If it is possible of taking a leap of two house, because yeah, I think this is certainly possible. So let's take the example of here. Uh, where's the text? So if you see here, let's say the number that is here is 1, and then there is 2, 2, and 5. Make it 1, make it 1 here as well, and make it here 2. Now person can go to 2, will take 2, then we'll take 2 again. He cannot take 5. Take 2, then he will take 5. That way he will have having the maximum. So in that case, what the person can do, I think that approach to be the better one, starting from here and then checking whether we should take or we should not take. Yeah, let's go and solve the problem. Yeah. So let's think about the problem slightly more. So here, if you see the answer is 15. It has carried by 0, 2, and 4. So this is 0. And then 6 is 4. Yeah, I think these are the two options we can have that, and then we can build. So let's think about. Uh, let's take rest one. Let's take rest one, comma rest two. Uh, let's take rest one is equal to zero, and rest two equal to zero. So we have these two things. Now let's say n will be the length of nums, and from here for say a is equal to 0 is also equal to 0 for let's say nums in for I in range uh I comma n minus 1 uh, temp, let's say temp will be equal to the max of nums uh, of a max of b comma a plus nums I, and then b equal to b, and then b equal to temp, right? So here uh s1 will be equal to b, and then again b is equal to 0 and a equal to 0 as well, and then from for I in range, 1 to n, can do is can say temp equal to max of b comma a plus nums I. This is exactly the same. Nums I a equal to b and b equal to temp. Then we have to return max of b comma s1. So given nums is equal to 0, we just have to return 0. These things can be read as a base case. So we can say if uh, here what we can say here, like uh, if n is less than 0, so as n is 1, we can return nums of 0. If n, let's say equal to 2, we can just return max of nums of 0 and nums of 1. So yeah, this is submitted and correct, but now I think there's a lot of improvements that is required. So yeah, let's work on them. Let's This also work. This will also work. Yes, right. So what better can be done is just reset, and we can say if n is 1, re- okay, let's take the size. So we can say n is equal to length of nums, and if n is 1, just return nums of 0, otherwise return max of let's say solve. What will go there is, okay, solve nums, uh, and then what will go there, and here will be the index I, and j, right? So here it will be 0 and n minus 1, comma, solve nums 1 and n, right? So here it will be like def solve things go here will be nums, be I, there will be j, right? Then the part of solving equal to 0, equal to 0, or index and range I to j. What we have to do is temp will be equal to max of b a plus nums index a equal to b equal to max of and b equal to temp and return b. I think this should work as far as I believe. One index, no need. Don't know if it is done this way. Yeah, this is working. Let's see the solution. So the solution is space optimized solution. Yeah, here. So they have a helper function which is approximately the same that they are doing the prior. They are returning the maximum of. Oh, they have also taken num zeros. That they also contain that. Then from n to n. Okay, they are just transferring the nums. Right. Okay, because they are transferring the array, so okay, it's also okay. Yeah, I see. Pretty similar. Let's go to next question. So longest palindromic substring. So this is substring, right? So given a string S, we have to return the longest substring of S, that is palindrome. See here there is BEB. So a palindrome is a string that reads the same forward and backward. So if there are multiple palindromic substring that have the same length, we have to return any one of them. Alright. So yeah, let's do this. So I think in this question, one of the concept is, so if you see clearly, we have the s, that is a string. We have, so what if we reverse the string? So let's say we have a string that is reversed. So in that, what we will be having here, it will be, I think, reversed, something like that. Reversed is something like this. So now if you take, let's take the first example here. So here, if we see, what we have is, we have s, which is equivalent to ab and d. And let's say if we take uh, any other s uh, bar, let's say we have s bar, what is here, it will be, that is reversed one, or s rev, that is a reverse one, that will be dba. So now, when you, let's find out like what is the common subsequence in these two strings. So what you will see, okay, so common subsequence will be here, if you see, that will be b, a and b. So it will output bab, which is exactly what we are trying to achieve. So basically, when you reverse the string, and then the like, then your largest common subsequence will be actually your largest common parent, because when you're taking the subsequence, you'll be taking only those values that do align from both sides, because this side is reversed. Right? So since the other string is reversed, so when you find the longest common subsequence in the reverse one, that will be for sure palindromic. Yeah, because we'll choose a. Okay, whenever you get b, since we have also reversed it, you will also get b in the other one, right? Yeah. So yeah, let's find the longest common subsequence in this. So longest common subsequence will be given by, so given two string s1 and s2. So in the longest common subsequence, like let's say when we are taking like from the ith position of the first one and the jth position of the second string. So if they are same, meaning that if, let's say, if si s1 I say is equal to, let's say, s2 I, what we will be having is, uh, so when they are same, so there is a subsequence part, right? So that will be dpi to j will be equal to, obviously, 1 plus, because if we are taking that subsequence as a part of our answer, uh, that will be then the max that we'll get in I minus 1 and j minus 1. But if we are, let's say, not taking, the maximum will be dp of uh, I uh, over j minus 1, right? And if we are, let's say, not taking them, then dp of ij will be the max of 1 plus dp of I minus 1j and dp of I and j minus 1. So when they're matching, certainly, yeah, the max will be, you will include this, and then you will check for the rate. If they are not matching, the max will be either till here, longest common subsequence that we form, or till here, because we have computed both of them as well. So let's implement this. So we have s, we can have s rev. Let's say is it is equal to reversed. Okay, s rev is reversed s, and now we have s rev as well. Now what we will be doing now? So now we have two substring. We'll just return uh, solve, and then it will be s and srev, right? Let's take def here and then let's just solve it. So here we have a string s. Okay, let's say we have a string s and we have a string s2, right? If let's say s1, if len of s1 uh, not len of s1, or if not len of s2, if any of the length of s1 and s2 is 0, if this is true or this is true, what we'll do, we'll just return empty string. It is not possible, right? And now what we will be doing is actually we have to return the substring, right? Correct. So okay, now we'll check at each of the ith and jth position how's the things are going for them. Right. We can also have a DP. Do we need to call recursion? I don't think so. Yeah, so I think this is not even needed. So here what we can do is let's say n is equal to n is the uh, length of s. You can create a DP, which will be equal to a string, right? So DP will be 2D vector of a string. So this will be of size n, right? So there are n of them. Okay, yeah. So I think this is, so the value is string and then there is the 2D DP. Sure. So this is the list of a list. This is our DP. And now uh so what if DP is 0? What does that mean? I think this will be of size n plus 1 for the obvious reasons, because it has to go till n, right? And what we'll be returning here is DP n of n. Okay. Now let's come here. So will be for DP 0 and 0. Mean that if any of the string is 0, I don't think there will be any reason to put any index on them, right? If any of them is 0, there will be no common. Okay. So which means that for our I will change from uh 1 to n. Yeah. So for I in range 1 2 n plus 1, this is what it will be. And for j in range, this will be 1 to n plus 1. Okay. If s of I is equal to s of j, so if s of I minus 1 is equal to s of j minus 1, meaning that if both the character are same, then dp of ij would be equal to 1 plus dp of I minus 1 j minus 1. So here instead of 1, it will be the character that will be added, I plus 1, right? This character plus this position, actually minus 1. This should be s rev, right? The second string that we have. Okay. And what if this is not the case? So if this is not the case, then our dpij will be equal to and j minus 1. This is the case. Our dpi or j will be equal to s rev j plus plus dpi minus 1 j minus 1, right? Oh, sure. Actually, I'm finding the longest. Uh, oh, I think there is one issue here. I am finding the longest common subsequence. However, this question is regarding the longest common palindrome that certainly required a different kind of solution. So I will skip here for now. I think I have submitted this already. No submission. Why is showing no submission? It is. This was done using taking each of the position and then yeah, maybe doing it for twice. So yeah, that's all. Sure. Uh, I'll see you. Bye bye.